how do we keep being productive after our project is more mature, has been released, it's been going for 6 months, had a number of developers work on it. How do we keep our productivity going? That's sort of the thrust of this talk. It's going to be a bit of a grab bag of different ideas, rather than pick sort of 1 or 2 ideas and go into them deeply. I sort of opted to take about 10 and throw them at you. So if you would like me to explain things further, please come up and talk to me afterwards. I'm here from Square. If any of this talk resonates you, you should come and work with me. It'll be great. The other reason I'm here is I get to practice a lot of this stuff, and we use a lot of these techniques at Square, and it's working out really well for us. So this talk came from, the basic premise of this talk is that this is what how Rails describes itself. This is front and center on the Rails website. Rails is an open source web framework that's optimized for programmer happiness. So that's probably pretty true. And sustainable productivity. I don't believe that is true. In fact, I actually think that's a bit of a lie. Rails is not optimized for sustainable productivity, and I plan to demonstrate why it isn't, both as a framework and as a community, and some of the things that we need to be doing better to address these issues. So let's start with one distinction. This is between a prototype, something you build very, very quickly. First couple of iterations, you're banging stuff out. Rails is great for this. This is like, and this is where Rails has come from. You might remember way back when, the 15-minute blog demo blew everybody's minds. Guys, we can build a blog in 15 minutes. That's great, but you've been working on your app longer than 15 minutes. You've probably been working on it months, years, been many, many people, and you actually need different things to be able to do each of these well. Another distinction is this easy versus simple thing, which Richie gave in a talk which I saw a while back, but he also gave last night, so that really helps me out, because I hopefully don't need to explain this term, because did everybody see the keynote last night? Yeah? So everybody knows what he was meaning by this, between the distinction between easy and simple, stuff that's kind of interleaved, that's complex, and simple things aren't, and the fact that they're kind of objective. Rails is easy, but it's definitely not simple. It's really, really easy. You can get a hand, you can get a blog going in 15 minutes, but in doing so, we trade off some simplicity. And that makes things really hard for us as our application matures. It doesn't have to be this way though. There are a number of things that we can do right now, which are the things I'm going to be talking about. And I think there's room to grow in our community as well. We have a lot more mature Rails applications now than we ever have. And so this is going to be becoming sort of more and more prominent, more and more people have to deal with this issue. I'm going to be tackling this in 3 parts. They're actually all kind of interrelated. When I was putting this talk together, I sort of trimmed it down to the stuff that I want to talk about, and then found that I had this sort of big ball of interrelated stuff. So this was sort of my attempt at dividing it up. They are all kind of interrelated. But I'm going to start with data. So your code exists to process data. And the simpler your data is, the simpler your code can be. That's sort of a fundamental concept here. And Rails, the way it encourages us to model and shape our data, is really not particularly good. It not only does it encourage poor techniques, but it discourages the better techniques we want to be able to use. This is my hypothesis here. This is sort of the strongest case against Rails I present in this talk. So let's start by talking about data integrity. So data that doesn't have integrity is data that doesn't make sense. It fundamentally is more complex than data that has integrity. Because rather with data with integrity, you know what's there, you know what it's supposed to be. With data that doesn't have integrity, who knows? You need branches and you need extra conditionals to support this data, you don't even know if you're right. Furthermore, data that doesn't have any integrity is confusing. If you're a developer, you're looking at a database, at some data, and you're thinking, I can't understand how this data got to be this way. That's just wasted time. Why are we having to worry about this? Like, if the data had integrity, that's something that the developer doesn't even need to think about, they don't need to fix, it doesn't need to confuse them. Data integrity is really important for writing simple programs. And this simplicity, which I forgot to mention at the start, this simplicity is where our productivity will come from, which is, I think, a case Rich made quite well last time. Let's start with a case most people are familiar with. Validates uniqueness of. It's a constraint, it's a validation. We put it in our model. We say there should only be one user with this name in our database. course, there's a race condition. If you get two requests coming into your server at the same time, often happens when somebody double clicks a button, for instance. And first one checks the database and says, oh, there's nobody with that name here, I'll insert a new record. Of course, the other process is doing the same thing at exactly the same time. Checks the database, oh, nobody with this name here, it inserts a record. And we end up with two records in our database, both with the same name, and both records are now invalid. You have data that lacks integrity. This is a well-known problem. It's even in the Rails documentation, it calls this problem out, and it says, in essence, hey, you can use a database constraint and it will fix all your problems. Which is great advice. If you have a validation you need to solve and you don't have a unique constraint in your database, go fix it now. Well, after this talk, don't fix it now. Pay attention to me. So we've called this out as a problem in our community. We say, oh yes, race conditions is going to happen, we're on the web, that's how things work. We need a database constraint. Which is great, but then what happens when that database constraint actually gets hit? Raises up an exception. And the first part of this control looks fairly similar, but the second bit, it looks kind of weird. We don't look or talk about code like this. Like, I'm sure everybody in this room could come up with something pretty decent to go in that rescue block. But everybody would come up with something different. There's a number of ways of dealing with it. And this is a pattern which we haven't really dealt with as a community. We don't know how to deal with uniqueness exceptions. And this is a real problem. Like, this is one of the fundamental things you have to deal with web programming. We have to handle concurrent requests. And we have a framework. And so I would argue that a framework should support this thing that we have to do. And Rails doesn't. It doesn't provide a way to say, oh, you don't want to have uniqueness in the database and deal with that in a consistent manner. And we have to do both the validation of the database and something else to deal with the actual concurrent case. And this is a problem. This leads to people reinventing things. It leads to more complicated code. And actually, more scarily, it leads to people not even thinking about the problem. So we can take this case of validation uniqueness of it's race condition, and everyone's like, yep, that's a problem. We've got some solutions to deal with it. They're not great, but we've talked about it. Let's say it has one relationship. We say a user has one account. Of course, we've got the same problem. We get one request on one side that says, hey, create a new account. We get another request on the other side that says, hey, create a user account. What are we going to end up with? Two accounts in the database. Now, yes, it's a little bit rarer than a uniqueness violation, but this happens. I've seen time and time again in Rails project after Rails projects has one associations which have 2 or 3 or 4 records, child records in the database. And I look at that and I think to myself, this doesn't make sense. And then I have to go and fix it. I have to figure out what's right, what's not right. How did this happen? Does the bug still exist? Was the bug from 3 months ago? It's all this extra stuff which I'm doing. And if I'm doing that, I'm not being productive. Of course, solve this with the same tool. The unique constraint on the user ID on account fixes the problem, then you still have what happened when that breaks. Has any relationship. Exactly the same problem. You create a post on one side, you delete a user on the other, you've got this stranded child record in your database that's not pointing at anything. It's confusing, right? And in this case, we can use the same technique, a foreign key, it's a database constraint, to solve the problem. But this isn't acknowledged in the Rails community. It's not in the documentation, people don't use them. And this is a real problem because these relationships and uniqueness, this is where we have a really high risk of data corruption. So I'm not arguing for, oh, let's put everything back into our database. I don't want to have store procedures that validates email addresses in my database because once I've got an email address through my app validations and into the database, there's not really any sort of reasonable way in which that is going to break, right? I mean, you need a malicious developer to pretty much go in and do an update for, right? And then, like, that's not really high risk, right? Compared to, oh, any sort of concurrent access to this thing, that's high risk. I've seen this on this isn't just something that, oh, I saw it once on a project. Every single Rails app I've ever worked on, I've worked on probably five major ones, plus a host of small ones. They all have these data integrity problems. This is a serious problem for all apps. And these relationships have a really high risk of data corruption. It happens. But we've got tools. We know how to fix this. This isn't a new problem. This isn't unique to the Rails community. This has been solved in any community that has to build things for the web or any sort of concurrent environment, which is pretty much everything. Database constraints are the best tool to do this. There are other ways. We can do it reactively. We can run a script to say, hey, look for any duplicates and flag me and say, hey, I've got duplicates. But that's kind of expensive. It's kind of a pain in the ass. You can do, I guess you can do some sort of cross-process locking when you're inserting stuff. Once again, pain in the ass. Database constraints are just the best, easiest, cheapest, simplest way to do this. Rails doesn't support them. Yep, it's got some basic support for uniqueness constraints, non-null constraints. But on the whole, Rails is very antagonistic towards using database constraints. And this comes right back from the early philosophy of Rails. It's like, oh, the database is just a big hash in the sky, and we can do everything in Ruby land. That is just patently false. We cannot do that. And Rails does not support database constraints. Rails does not support the best tool for the job. This is embarrassing. Here's just a bit of a list. The no conventions I just went through. Fixtures, not that anybody really uses them, but they're still in Rails. They don't support foreign keys. The RB schema format. It's kind of useless. It only does things that Rails knows about. So if you try and use a foreign key, for instance, it just gets ignored by the schema format. Of course, you switch to the structure number, but then the MySQL one, I think they fixed this in 3.2. But up until very, very recently, the structure number would dump the tables and the unique constraints, but it wouldn't dump the foreign keys. Migrations. We don't have a good way of adding a foreign key without writing SQL. Which actually is fine. SQL's not that bad, but we don't talk about it. A polymorph relationship. So this is something I haven't really spoken yet about. I'm going to go into more depth. But we have these sort of best practices which are antagonistic to modeling data in a way that is simple. I'll talk about that a bit more. So this is a polymorphic relationship. And you've got a user, you've got a post, they both have comments. We're like, oh, they both have comments, we'll store them in the same table. This is kind of annoying. Like, you can't put a foreign key constraint on this, so you can't avoid the race condition. Indexing the comments is kind of a pain. Doing that with different quantities of data, like sometimes users will have very few comments because they're like admin-only comments, and posts will have a heap of comments, but every time now you want to show a post, you have to deal with the user comments. It just adds complexity. It's easy to start. It's easy. You just go, oh, it has many polymorphic. But as your app grows, and as you get more data, and as you try to evolve your app, it's a real pain. There's two other techniques which we could use. Here's one. Just store them in separate tables. This isn't a violation of dry. I've spoken to people and they're like, oh, it's not dry, you're doubling up. No. Dry is about code. Dry isn't about your underlying sort of data structures. A user comment and a post comment are probably two fundamentally different things. You probably don't need to aggregate them together. You don't need to give me you probably don't need a count of all comments in the system. And you can still have dry model definitions for this. Like if they have very similar behavior, use a mixing. Use a module, that's what they're for. So this is one other way. If you really do need aggregation across all comments, you can do a pattern like this. Once you're sort of starting to go down this road though, you can also start looking at some sort of more schemaless type solution to it. My point being that there are other ways to do polymorphic relationships without actually using a polymorphic relationship, and they are much, much simpler. But they're not something that we really talk about. We go for the pretty DSL rather than the simplest thing that enables us to be sustainably productive. So that's all I want to talk about data for the moment. Or actually not quite. I want to talk about code in the small. And by this I mean kind of nitpicky small things about how we write code. Now I don't actually have any problems with the Rails framework here. There's just some things that I think as a community, like the best practice and the way that seems very written, that I think we can do better. So this isn't oh, we're doing it totally wrong, we need to do it a totally different way. This is just a collection of things which I think we can get better at. And the first one is about how we sort of represent data inside our code. It's kind of a little bit of a segue. So I'm going to show some code. This is for a tool that I wrote that I'm going to show. This particular bit of code is, it's looking at a file, coverage percent. And then it's comparing a number that it reads out of that file to the given number. So it's saying, is the coverage percent greater than 90? So here was my first cut at writing this. And I've just highlighted bits that I definitely want to read. This is just a snippet of code which reads a file, jumps it, 2fs it, sends the operator, does a comparison, and generates a violation. So if it's under 90, it'll return a violation, otherwise it returns nil. Of course, if the file's not there, we need some error handling, and we also want to create the violation and just say that the file was unavailable. And you look at this, and you think, oh, that's fairly reasonable, right? You feel a little bit niggly about the violation.u kind of looks like it's a little bit of duplication. But generally, this code kind of looks all right. Well, it did to my eye. But then I started thinking about it in this context of simple things and complex things, and in particular, the braiding of different concepts. And with that eye, you can look at this bit of code and you say, well, it's actually doing a couple of things. It's doing file access, and it's doing business logic. So what does it look like if we separate those out? Here's one way. Sorry, I kind of crammed it so that it fit on the top of the slide. But here you can see I've separated them out. I said, okay, read a value from the file, and then do the operation. And what's interesting here is in order to do this, I've introduced a new concept, unavailable value. And so now we've got this new thing to talk about. And I think this is, and we've also got this new thing to document and say, hey, this is an unavailable value, this is why we use it, this is why it exists, as opposed to our original snippet where it was kind of implicit. And this technique, score verification, it's sort of taking something that was abstract or implicit and making it explicit. And I argue that this can actually make code simpler. That's counterintuitive. We're adding something to make it simpler. We're not always taking away. We've actually added a new concept to the system, which now has something we can talk about, something we can document, and that's given us a good way of splitting up our system. And I found this to be a really, really powerful technique. To give you a concrete example, in the Square web app, we had a number of different places where we were creating users. And there was some differences between, it wasn't exactly the same code. Like, it wasn't a copy-paste job. There were actually some variations there. But it kind of got to be a pain, because we had sort of a bug in one spot, and then it didn't get fixed through the other spots. And it's also kind of confusing. You look at the code and you're like, this looks familiar, but I don't really know. So what we did is we pulled out this user creation object. So it's just a class, and it was where all the user creation stuff went. And then we could just subclass it for web sign up, API sign up to customize it. We provided the books there. And this was great. So we now had a place to extract this common code, and we had a place to document the process of creating a user and what that actually means within the system. This brings me to class documentation. Class documentation is really, really important. There's been this backlash about comments where people are like, oh, you write code and the code should speak for itself, and the code should be self-documented. Yes, your code should be self-documented, but that can only cover a certain type of documentation. Whereas class documentation, if you're describing how this class, it fits into the bigger picture, some of the sort of things that you can't and couldn't tell from looking at the code itself. You can't replace this high-level documentation with self-documented code on anything but the very smallest of apps. To give an example, a couple of weeks or a couple of months after I started at Square, I was on call for the first time. So I was the first point of call. If anything broke, I get a text message and it said something broke. Figure out who needs to fix it. Figure out if you need to fix it. Figure out what the deal is. And so I got a page one morning. I'd just woken up. It was 7 a.m. and it said the ship team audit job has failed. I was like, oh god, something failed. I need to fix it. So I logged on and jumped in. I was like, okay, let's go to the job. Loaded up, and I got this. And you look at that, and that's actually pretty self-documented code, right? I mean, it's a job, it's got a perform method, it serializes the reader request, it submits the order, it completes the shipping batch. Well, all right, that's great. But what? Do I restart it? Does somebody care? What do I do? So I have self-documented code, but it doesn't actually answer any of the questions I have about this code. It doesn't answer any of the important questions that I need when I'm sort of investigating and diving into this code for the first time. I'm not oriented in the system. So I finally figured it out. I chased around for a couple of hours, found some people who cared, and I wrote up some documentation. This is just some sample documentation that says, when you open this class, you can get a feel for how it fits, right? And this doesn't necessarily have to be at the top of your class. The reason I like it here is because this is normally your entry point to the code. Like, you can have some high-level architectural documents, but nobody's going to read them. You get an exception, you're going to go to the line in your backtrace, right? And you want to be oriented as quickly as possible. Now, yes, you can move this out onto a wiki and put a link from the class header or whatever. If there's a lot of documentation about a class, I tend to do that. But if it's just a couple of paragraphs, I find this works really well. And I know this is a good idea, because when I first started at Square, our job didn't have class-level documentation. So I put this one in. And then I did that, I did another one, I was like, okay, that's great. I came around one call 3 months later, all of our jobs had class-level documentation. It was just somebody saw it, they're like, this is really useful. I need to do this. And now, it's really easy. If anything fails, you can log in, you can see, oh, I need to talk to this person. Or, oh, we can fix that later. Or, oh God, I need to get this fixed as soon as possible. So that's worked really, really well for us. And now you'll notice that rather than spend 3 hours trying to figure out whether something's important or not and how to fix it, I can spend those 3 hours doing something more productive. And this is what I mean by sustainable productivity. These are the types of issues that crop up as you have a bigger code base. As the code base or your suite of code bases can't fit in one developer's head. You need to be able to provide clues, be able to provide hints, and focus on this micro-level stuff to help orient your developers. Consistency is also a form of documentation. Here's another job-related example, where this is a job with some retry logic. Now, you look at that, I mean, that's fine. You probably do it a different way, but you know what's going on. And that's great, we had this in one of our classes. There's another job, it's got some retry logic. And that looks fine, you probably might have written it kind of differently, but that's some retry logic. Now you're at your own job, and you're like, oh, and I better put some retry logic in. Do I copy this one? Do I copy that one? Do I have a retry time of 5 minutes or 10 minutes? Or are those important numbers that look important? Otherwise, why aren't they the same? I guess I'll have to ask somebody, what about retry count? 3, 4? Where do these numbers come from? Are they important? Now you see that I'm asking a lot of questions, which really are making me less productive. I kind of have to figure out the answers to these questions because I'm new to the system. You know, we take sort of errors and stuff pretty seriously at Square. You know, I don't want to be the newbie developer who's like, oh, you didn't do a retry count of 4? What were you thinking? So, when your code isn't consistent, every developer has to reinvent it. And this happens because we have, like, somebody will commit this, they won't even know this job exists yet. And then as time goes on, you get more and more of these jobs, and you get different retry logics. And this is just one example in the code base of retry logic that might have been invented 2, 3, 4 times. And every time slightly differently. And I think this is really interesting, because I talk to a lot of people about this problem, and they're like, oh, we've got a group of really, really smart developers, you know, we refactor our code, we make sure everything's nice. And I think one of my main points is that you can have a team of really, really smart developers, and they're still going to write inconsistent code, because it's just not possible for them to be refactoring the entire code base on every commit, unless you sort of make it part of your process and say, okay, which things will no longer be consistent. You need to explicitly bring this up. We're going to talk more about that later. So in this case, you know, we provided retry job mixing. It had sensible defaults for retry time and retry count and that sort of thing. It was very easy to use, so it was the easiest thing. So as a new developer, you start to write a job, you're like, oh, retry logic. I'll open up another job. Oh, retry on. That's easy. You open up another job. Yep, they all do it the same way. I feel good about myself reusing that same approach. There's extra benefits to this. If you override retry time, like you can specify a custom retry time here. But it's going to stand out like a sore thumb. But in code review, somebody's going to say, well, why did you do that? Why is that not documented? And that's really cool. Another big benefit, you get to share a set of tests. You only have to catch the edge cases once. There's actually a couple of edge cases when you're retrying jobs. And if everybody's reinventing it, somebody's going to slip up. Somebody's going to miss an edge case. Whereas if you can rely on common code, it makes things a lot easier and allows you to be sustainably productive. So this is the point I was kind of getting at before. It doesn't matter how good you are, you're going to slip up. This just happens. I've taken 99% here. I'm not 99% accurate. I'm not 99% productive. I'm not 99% correct. I'm much worse than that. But just for the sake of argument, you've got the best programming team in the world, and they very rarely screw up. Multiply that by 10 developers. Multiply that by 6 months. Multiply that by, all these compounding factors, and suddenly it's looking very, very likely that you're going to have some errors in your code. But the errors I'm actually not that worried about. Like errors, it's like, oh, it's a bug. It raised an exception. Let me fix it. That's fine. Errors we can deal with. Stupidity is a big one. Stupidity is stuff where, oh yeah, I just added an extra line to that method. And I thought it was cool because it was just a quick patch, and then before you know it, you've got a method that's 50 lines long. This happens because you're not always on your guard. If you're trying to fix a critical production bug, you're not going to be thinking about, oh, I wonder how complex this method is, right? It just slips your mind. No matter, this happens to me all the time. And where, I'm always trying to think about, okay, don't make the code more complex, don't make the code more complex. But I'm thinking about a feature, I'm thinking about business value. I just quickly move something around and then forget about it. And then, this happens. So we need tools and processes and techniques to stop us making these stupid mistakes as much as possible. Now we have things like pairing and code review to do this, but they're quite expensive. You need extra people. Pairing is like doubly expensive, right? So you pretty much want to use it for the things where it's really, really high value, but there are a lot of simple things we can check with machines which are far, far cheaper than pairing for the same thing. So things I like, basic style things, basic complexity metrics, readability violations as well, line length is a big one. And to do this, we've got a tool that I wrote in Square, we've open sourced it, it's called Cane. And there are a few other projects that do this as well. We did the one that worked on 193 and I had a few other requirements for it. But the point being here is not what tool you use, but just the fact that there's this tool. It tells you if you violated the style requirements. It tells you if you forgot to document a class. It tells you if your methods have exceeded some arbitrary threshold. Now, this one I kind of like talking about because a lot of developers are like, oh, we've got smart developers and that method, yes, it's got an arbitrary complexity metric of 20, but it's solid. It wouldn't be readable any other way. And to that, I think that's totally fine. Bump your threshold up. There's no problem with doing that. The number one benefit of this tool is you write some code, you go to check it, you run your specs, you run this as part of your spec run, and it says, oh, chill out. You're about to commit the most complicated method in this project. That's cool. I'm fine, but you're about to do it. Did you know this? Are you aware? And I guarantee that 9 times out of 10, you'll be like, oh, no, actually, I forgot to refactor it, or, oh, yeah, that's kind of getting ugly. I can easily extract a method there. So this is sort of my guard against human stupidity. This is my guard against my own stupidity. And I find this tool really, really useful. We've used this on a couple of our projects. And one of the prime benefits it's had is that it doesn't solve the macro level bad design things. That happens. What it does solve is the problem where you open up a file and you have this horrible gut reaction like, oh god, that code looks terrible. That is terrible code, we can't deal with this, the methods are too long, everything is horrible, we have legacy code. This fixes that problem. Which means that you now have nice, easily digestible chunks of code that you can read, you can understand, and then you can think, oh actually, maybe I need to extract that into another class. Or maybe I need to do these sort of macro level refactorings. So it sort of frees up your brain and it I just found that the code we've written using this approach it just feels much nicer. Which is great. It means I want to work in it, and it means when I'm moving through it, I can be more productive in that code base. One particular objection I do get from this from the developers on my team, especially when they first started, they're like, 80 character lines? What is this, the 80s? And me sitting on my laptop with big columns, I'm like, well, yes, but I'm sorry. I say that, okay, show me a line that's longer than 80 characters, which can't be expressed in a more readable way, less than 80 characters, and I'll up the threshold. Hasn't happened. Been 4 months. Hasn't happened. We had one where it's like, oh, look at this longer string. And I'm like, what if you use this string explosion? It's like, oh, that's much nicer. So, yeah, that's working well on my team. Of course, no tool like this is going to be perfect. Every now and then, it's going to call you. And you're like, oh yeah, this line actually maybe needs more than 80 characters, or this better is more complex. If you have a sufficiently high accuracy rate with your tool, you should conform anyway. In the very, very small percentage of times when you are right and the tool is wrong, suck it up, conform to the tool, because there is tremendous value in having 0 errors come out of your tool. The value that you get from that is worth more than your ego on one particular bit of code. So that's K. Check it out. I really like it. Third bit, code in the large. This is sort of the thornier one. The one I've just spoken about, they're kind of not particularly controversial. It's like, oh, here's some things that you can do. Not particularly hard. This is a harder section. This is how do we actually architect our apps in a way that allows us to be more sustainably productive. And there's a lot of people at the moment in the Rails community talking about sort of fast testing and this sort of thing, and solid OO design. And those things are great. I'm not going to talk about them mostly because other people are talking about them better than I am. I'm hoping to cover here a few things which kind of hopefully fill in some gaps, and things which I haven't really seen covered much. But if you don't know about solid OO and how to use mods properly, definitely I've got some resources at the end which I'll share with you, which you should chase up. I'm not going to cover them now, but they're really important. So the first technique I want to talk about is defining the relationship between your application and your third parties, effectively creating buffers for yourself. We were using Rescue to do a background job, to deliver emails. And this is some typical code. Okay, we have a mail delivery job, we queue it with bits and pieces. There's a problem here, because we reused this throughout our code base. It was always mail delivery job or something delivery job. And you end up with code that looks like this. You have code that's depending on code that you can't change. And that can screw you. It makes things very, very hard to upgrade. Maybe you need to upgrade Redis and then change your Rescue and then change your interface. Or if you want to sub out Rescue. Or even if you just want to intercept and put some extra code in between the emails going out of your system. Like sometimes on staging you might want to filter them, or you might want to redirect them back to another email address, or whatever. In this case, there's no good place to put that. You can't change the third-party code. Well, you can in Ruby, like monkey patching, which is the problem. That doesn't help. That just makes you less productive, because everybody has to go and figure out how the whole monkey patches work. But this is a problem. It's got a really easy solution. You just put a layer between your code and the external library. In this case, it's really just a rename. Square-mail.deliver. It's fairly simple delegation, straight through to Rescue. But in this case, it means we have like this. We've defined our relationship with Rescue in our terms, not Rescue's terms. So now we have this concept. This is a concept, rather than a technique. Right? This is implementation. This is an interface. We get code just like this. And this is awesome. Once we put this in, we actually did have a requirement. I can't remember exactly what it was, but we had to change the way we were delivering email. And it was trivial. We had the square mailer class, we had the deliver method, we could just change that. That worked really well. Another example, I was talking to somebody about this yesterday. Redis. I see the Redis constant everywhere in code bases. This sucks. For the same reason. We've got that same graph where we're depending everywhere on a third-party library. And once again, we've got this problem between implementation and an interface. The best way to fix this is to put a layer in between yourself and Redis and have it describe the actual thing that you want Redis to do. If I see this code, I'm like, great, we're using Redis. But Redis does a lot of things. Like, do I want a queue? Do I want a key value store? Do I want, PubSub or whatever else Redis does? You don't know. The easy way to work around this is to actually put a thin layer between yourself and Redis to say, actually, I want a key value store, or a persistent key value store. It doesn't really matter what, or a user cache in this case. So this is like that up. Maybe it doesn't even have to be persistent. But what this does is it means when I read in this code, I don't have to figure out why the hell we're using Redis. I just say, oh yeah, key value store, I know that concept. Or, oh, queue, I know how that works. I can push and I can pop. Right? And like the queue, it might be Redis, it might be backed by Postgres, it might be backed by AnyQP. Who cares, right? You probably want 3 queue functions. So put that into your app, define the interface that you want from your external library, and you end up with a graph that looks like this. And you get much more malleable code, code that you can push around, code that you can understand, and code that you can be more productive working with. Second point. This is a sort of, this is an object graph, not from Square actually, this is from a previous project I worked on. It was an online newspaper. Had some CRM, had an editing interface and that sort of things, CMS, thank you. And this was our object model, or sort of a cut down version of our object model. And we started with this, and we were like, oh, they feel kind of similar. Like, maybe we want to do STI or something like that, but no, we modeled them out, and they had different behavior, they had different attributes, they were separate things. And we were kind of wary going forward with this sort of double hierarchy. But, we thought, oh, we'll run with it. And it turned out that the mistake we made wasn't splitting out the hierarchy. We made a different mistake we didn't see coming. With this sort of setup, we ended up with a graph that looked like this. We had controllers or models. Concretely, it kind of looked like this. It's great. Oh, we're creating a draft. So we've got code actions on our active record models. We just create a code controller, and we simply create an update on the draft. That's what screws. The point being that we had this, and then we had to change all the models around, which we did eventually. We had bits talking to every other bit, and it was very complicated to do. So a way to address this problem is using what's called an aggregate. Somebody talked about this, I think briefly the other day. Keith mentioned it. He's a mentor source. An aggregate is cluster of associated objects, and then we treat it as a unit. That treating as a unit is a really important concept. As it comes from domain-driven design, well, that's where I read about it. It's a really good concept. But not only that, the root is the only member of the cluster that the controller or outside object is allowed to talk to. So in this case, if you make article the aggregate root, it's a fairly simple change to the code. Article.create graph rather than article graph. But what it does is it gives you a dependency graph like this, which means that if you need to change around the component bits of the aggregate, you don't need to change any of the external references to it. And we found that is actually the path we went down when we found we had to refactor this. We put in this aggregate concept first, and then we were able to refactor it in the back end. That worked really well. In this case, it looks pretty easy. It's like, oh, we had a draft, we have obvious root objects. If you've got an order with line items, it's kind of obvious the order's the root. But in practice, I've actually found this very difficult. I'm not very good at picking aggregate roots yet. This is one particular bit of advice I found kind of useful. If you're relying on like bidirectional associations, as in you have an order has many line items and a line item belongs to an order, that belongs to relationship. It's the same, you have a child talking back up to the parent. That's I found that to sort of be a symptom that you might be ignoring this concept. Ideally, you code deploy downwards. You don't want cyclic dependencies where possible. That's not to say that bidirectional associations are always bad. I'm just saying, it's a flag that I've found. So this idea of aggregate roots I found really useful. So here's another big one. This has been tackled a lot by sort of fast test movement, if you like. I don't know if it's movement or not. Probably is. but treating active records as a data structure separate from business rules. Separating out your business logic from your systems. And here's one way of doing it. There's many. You can wrap a presenter around your object, and then you can test this in isolation from the database. So that's great. That's one way of doing it. The problem I want to talk about is that we don't have the tools or the language to be able to do this because Rails hasn't provided them to us, and it's annexed the language that we want to use. This is the Rails definition of different levels of testing. Integration test, testing controls. Functional test, testing controls. Unit test, testing models. It doesn't tell you how to test them. It doesn't tell you what layer you're testing them. This is just a convenient convention for where to put shit. I mean, yeah, that's great. Don't get me wrong. Convention is very, very cool. But there's a lot more that Rails can be doing here. In particular, I want to take objection to the annexing of the definition of unit test because this definition of unit test is totally broken. It is so wrong. Nobody else anywhere ever uses this definition of unit tests. That's a big problem. This is set development back 5 years in the Rails community. I truly believe that. A unit test doesn't hit the database, it doesn't hit the file system. And these are all for very, very good reasons. Right? I'm not saying that you shouldn't test your models by hitting the database, but that's not a unit test. If we use this definition of a unit test, what it means is it opens up this whole new world of literature that we can use to help address this problem for us. The Java world has been doing this sort of unit testing for years, right? And then the other communities as well. We can reuse the techniques that they've found, that they've discovered, rather than trying to solve the problem ourselves all over again. So, if those definitions aren't useful, what are some useful definitions? Well, I've tried a few. These are the three that I've found to be really, really useful. Acceptance test, does the whole system work? End-to-end, doesn't work. Integration test, does our code work against code we can't change? So third-party drivers, file testing, etc. And do our objects do the right thing? I've taken this from Growing or software by test. It's a great book. I've been using these definitions on my projects for about a year now. As in I have spec/unit, spec integration, spec acceptance. And it's great for a couple of reasons. One, it gives me access to two different types of testing that I didn't have before. Unit testing and acceptance testing. If you look at these definitions, they're all integration tests. So by using these definitions, we've effectively combined ourselves to only using integration tests by these definitions, right? Which means we've cut out acceptance, we've cut out unit. Now, we've kind of got around that, and most people sort of through Cucumber started doing acceptance testing a lot better. But the unit testing, we now have to call them like fast tests or fast unit tests, which is kind of silly because you can unit test something big. You can't really unit test a controller, it's got action control testing, but you can unit test any class in your system, right? These unit tests, this is where the design part of TDD comes from. We're not very good at test-driven design. We're good at writing tests, right? Doing tests first. You're not very good at the community at doing the design part of tests. Because this unit test, this type of unit test where you use mocks and where you start out your dependencies, it forces you to be explicit about what you're depending on. If you're doing this sort of thing, it makes getting this sort of graph really difficult because you have to be explicit about what you're talking to. Normally, Rails just auto-loads up everything. You're like, oh, I'm going to talk to this thing in lib, and I'm going to talk to rescue, and I'm going to talk to the database, I'm going to talk to the file system. You don't have to think about it. Whereas if you're doing unit testing, it forces you to think about these things. And this is what gives you the tool. This is the tool that forces you to sort of move towards this type of thing. So unit testing are what sort of enables this, and it enables better design. And yes, it enables fast tests, but that's a side effect, right? If you're trying to test every single branch in your system at the integration layer, you're going to get a test suite which has great coverage, but it's going to take hours to run. And this is the problem. So many people have figured out ways of splitting up their tests and distributing their tests and whatever. And this, everybody just takes this as a thing for granted. It's like, it's something we have to do. The Rails app's a year old, we have to distribute our tests because they take ages. It's because we test all of our branches with integration testing. It's stupid. We've missed out on these definitions. I've also found these definitions really useful for new people coming onto the team, learning Rails in particular. They're able to sort of see these and think, oh, okay, that makes sense. You know, they can use these to figure out how they're supposed to be testing rather than just where they put files. Because convention is important, but it's not really that hard to enforce. You say, put it in this folder. Done, right? Whereas these actually give you a context for thinking about your tests, which I think is really important. Language shapes the way we think about these problems, and language shapes the way we code. So these are the three things I've just talked about. Data. Your code exists for data. Foreign keys are really cool, you should use them. Coding is small, use Cane, it really helps with this. Coding the large, that's hard. I don't have any quick win advice, but read some books if you haven't already. And practice. I'm not the best at it yet, I'm trying to get better. Here's a list of books, list of websites, list of videos. I'll put these up on the internet somewhere so you can get them. I've been reading a lot over the last couple of years. These are sort of my picks. Other people have different ones, but if you read them, you can't go too far along. So just to finish up, this is a quote here from Sandy Metz. I think it's here somewhere. There she is, Sandy. Thanks. So, Sandy gave a talk at Rico a couple of years ago, and I watched it. And she was talking about solid OO design, so not exactly the same thing I've been talking about, kind of the same thing. And up until this point in my life, I sort of saw this arc towards legacy code as kind of inevitable. Like, the longer I work on the project, the worse it gets, and eventually it will suck and we'll have to do some things. This matched my experience, it didn't match my ability. I certainly was writing software that was doing this. And I was like, oh, well, I guess I'm going to have to live with it. And I pulled this quote out, and I've never forgotten this, because Sandy was talking about software that they've been working on for years. And actually, rather than this arc to the dirt, software actually got better and more fun to work on over time, as time progressed. And I thought, wow, this to me was a glimpse of something. But I don't know how to do that, but I wanted to. And for me, that's why this is important. Yes, we want to create business value. Yes, we want to have robust things. Yes, we want to be good at their job. But for me, honestly, I just want to have fun when I'm working, right? And for me, I'm not quite there yet. I still have a lot of things to learn. But for me, this sort of opened my eyes and gave me something to work for, and sort of convinced me that it was sort of worthwhile to learn all this stuff. So that's me. Thank you very much.